Hello everyone. Welcome to Agri Addict YouTube channel. I'm your tutor Sakhi. Today I'll be teaching statistics measures of central tendency. This is my short intro. I have done my undergraduation from Jawaharlal Nehru Krishi Vishwavidyalaya Jabalpur. Currently I'm pursuing masters at IRI Hyderabad Hub Creda, Department Agronomy. I have secured All India rank 12th in ICAR PG 2024 examination. So let's start the lecture. Today we'll discuss the measures of central tendency. It is the value of variable which is representation of entire distribution and is called an average. For say we have a data 5, 2, 4, 2. This is a data series we have. So a value which represents the whole data, this value will be known as the average or the central tendency for this data. Okay, I hope you got the point what is central tendency. There are five measures of central tendency. First is arithmetic mean. Second is median. Third is mode. Fourth is geometric mean. Fifth is harmonic mean. Okay. Next, characteristics of ideal central tendency. It is very important. It can be asked in the examination as which of the following statements are correct regarding ideal central tendency. So first is it should be rigidly defined. Second is it should be easy to understand and easy to calculate. It should be based on all observation. For say we have this observation 5224 and we are taking only two observation, not taking the other two. Then the value which will be coming will not represent the whole data. And we studied in the previous slide that central tendency is the value which represents the whole entire series of the data. So if we are saying that ideal central tendencies characteristics, so it should be based on all the observations. Okay, it should be least affected by fluctuation of sampling. For say we have a field and there are plants and we have to take the plant height. So for say one student is allotted here, student A and student B, to take the data from the same field. So value obtained by student A might be different from student B. But when we'll be calculating the measures of central tendency or the central tendency, then the value should come same. Or value not exactly, then near to same it should be. Okay. So this is what the fourth point says. It should be least affected by fluctuation of sampling. Because if two persons are doing same work, then the efficiency or maybe some difference will be there. Some error will be there in between these two. So there might be fluctuation in sampling. So the observations will be different. So the results will be different if the central tendency is not ideal. But here, what we are considering is it should be least affected by the fluctuation of sampling. The fourth point is it should not be much affected by extreme values. What does it mean? For say this data I have taken, in this I include 86. Okay, so we have 5, 2, 2, 4, and 86. Then suddenly here we are saying that 86 is a very big number compared to 5224. So the value which will be coming, the average will be coming, it will disturb, like the average will get disturbed by this extreme value. If a central tendency is having is being affected by this extreme values, then it will not be considered as ideal central tendency. So fifth point, you should remember that it should not be much affected by extreme value. The values of this average should not shift by if we are considering this if there is some extreme values in the data. Okay, it should be capable for further mathematical manipulation. This is the sixth point. You should remember all the 6 point. It can be asked, and as I said earlier, it can be asked as statements which of the following statement are incorrect or correct about the characteristics of ideal central tendency. Okay, let's move to the next slide. So let's start with the arithmetic mean. So mean is the value which is obtained by dividing the sum of observations by the total number of observations. We will understand it when we'll make the formula by this this definition. So Second point is most commonly used measure of central tendency is mean. Okay, it's very important. You should remember this. Mean is affected by change in both origin and scale. What does it mean, origin and scale? Origin means if we are adding something in the data or subtracting something from it, then the mean will also change. It is going to be changed. And change in scale means if we are multiplying the data with something or dividing it by something, then also the mean will change. Okay. First, say we are taking a scenario where we have a data, we are representing the data by D, and we are adding something into each values for say 2. Then the new mean which will be coming in that, the 2 will be added. Okay. If we are subtracting something for say 2 from the data, then the mean will also be changed by -2. If we are multiplying the data by 2, then the mean will also get multiplied by 2. If we are dividing by 2, then the mean will also get divided by 2. Okay, I hope you got this point. So I have included this question. If each data is changed by 2 times, then mean will be changed by 2 times. Because if the data is changed by 2 times, then the mean will also change by 2 times, just like I said here. So it should be 2 times. Okay, let's move. So yeah, here we will derive the equation for it from the previous definition. First, wait a minute. Arithmetic mean is sum of all the observation divided by total number of observations. For say we have this x1, x2, x3, dash, 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 to xn. These are the number of observations and n number of observations are there. So if we want to make a formula from it, so what we'll do, we will add all the information like x1 plus x2 plus x3 plus dash 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 to xn. Okay. Divided by the total number of observation, that is n. We can construct it and make it simpler version like summation I is equals 1 to n xi divided by n. This is the summation and this is the total number of observation. For say we take a question and we have to calculate the mean. For say we have 2, 4, 4, 6, 2. Okay, this data we have. And now we have to calculate the arithmetic mean. So what we have, the formula is summation of I is equals to 1 to n xi divided by n. So in that what we have to do? Here we have to see what is the n. N is 1, 2, 3, 4, 5. N is 5. Okay. So what we'll do, we will add all the observations 2, 4, 4 plus 6 plus 2 divided by 5. Here we will add this 6 plus 4, 10, 10 plus 4, 14, 14 plus 2, 16, 16 plus 2, 18. 5 3s are 15. Okay. And then 5 6 are 30. So here our mean will be 3.6. Okay, I hope you got this point. Let's move. Here I have included the characteristics of mean. It is the simplest average to understand and easiest to compute. As we studied in the previous slide, it is simple. It is very easy to calculate this. Okay. Next, it is affected by value of every item in the series. In the previous slide, we studied that we added every item of the series. This is the data series we got. and we are adding all the item in it. Matlab, we are considering all the values given in the data series. So that's why we are saying that it is affected by value of every item in the series. It is defined by a rigid mathematical formula. We saw that sum of observation divided by total number of observation. Now we can say this is our mathematical formula. So it is defined by a mathematical formula. Okay. Then algebraic treatment of mean is possible. We can we can treat algebraically mean. It is not affected by position of the series. Here, if we'll change the position of the data, the summation will not differ. It will come to 18 only. Okay. So here it is not affected by the position of the series. Okay, just like in median, it is affected by position, which we will study in the next series, next slide. It is not affected by the position, but median is affected by position. Okay, next is our median. So a value of variable which divide data set into two equal parts when the items are arranged in either ascending order or descending order. Means there is a data set for, say, this line is a data set, and we have to divide it into two in equal half. So this value which is going to divide it into two equal half, that will be termed as median. Okay. So median is the second quartile and 50th percentile that divide the whole series into two equal parts. So first we'll have to know what is quartile and what is percentile. For, say, this is a data series and we have to divide it into four equal parts. So we'll be needing three quartiles. Yeah, these are three positions which is going to be divide the series into four equal parts. Okay, it is Q1, Q2, Q3. That is quartile 1, quartile 2, quartile 3. This quartile 2 you are seeing, it is dividing the whole series into two equal parts, as you can see here. So this Q2 we can say is median because it is dividing the whole series into two equal parts. So that's why we are saying that median is the second quartile. Okay. And then 50th percentile. Percentile, when it comes, it is, you can say that it is 100 parts we have to do. Okay. First, say this is the data. Let's make it here. First, say this is the data. Okay. And we have to divide it into 100 equal parts. So what we'll do, we will make 99 percentiles here. 99 such division lines. And when we'll come from here to 50th one, this one, or here to 50th one, this means 50th percentile, it is going to divide this data into two equal parts. And in the previous definition of median, what we said, any of the value which divide the data into two equal parts will be considered as median. So 50th percentile is also equal to median. Okay, I hope you got the point. Now, next point. It is also known as positional average. We are studying about position. It is the positional. We can't say that median can lie here or here. Median will lie in between, which will divide the data series into two equal parts. So that's why we are saying that median is also known as positional average. Okay. Median is used for studying qualitative data. Qualitative data which cannot be measured. A data which cannot be measured. For, say, average honesty. We cannot measure. We can say that this person is honest or this person is not honest. But we cannot say that this person is 1 kg honest or 1 centimeter honest. And the second example is average intelligence. We can say that some person is intelligent or is not intelligent, but we cannot say that it is he or she is 1 kg intelligent or 1 centimeter intelligent and he or she is not 1 centimeter intelligent. We cannot say that. So the qualitative data is the data which cannot be measured. And there is second kind of data also, which is qualitative data. Okay. Qualitative data. Qualitative data is the data which can be measured. Like plant height, like plant girth. This we can measure. But like average honesty or average intelligence, these are the qualitative data which we cannot measure. Median is generally used in agriculture, as in case of if we have to find the medium seed size, then the median will be used in that case. Okay, I hope you got the point. Let's move to the next slide. Okay, now we'll know the formula how to calculate the median, and we'll see an example also. For say if n is equals to an odd number, it can be 5, 7, 9 like this, and n is equals to an even number. In both the case, we will discuss how we'll calculate the mean. In case of odd one, what we'll do, the median will be n plus 1 divided by 2 observation. It's simple, very easy to calculate. When n is even, then what we'll do, median will be n by 2 observation plus n by 2 plus 1th observation divided by 2. Okay, let's take an example of both this thing. For say a question is there 2, 2, 3, 4, 5. Here 5 is there, n is equals to 5, which is odd. Here we are taking 2, 2, 3, 4, 5, and we are taking 6 also. Question. Okay. Here n is 6. Now the first thing we have to do is we have to arrange it either in ascending order or in descending order. Here we are saying it is already arranged. So what we'll do, we will just put the value here in this formula and get the answer. Median is equals to, what is n? Here n is 5 plus 1 divided by 2. Okay. Observation. 5 plus 1 is 6. 2 threes are 6. It means third observation is our median. So here the median is 3. Because this data is already arranged in ascending order, so we are not changing it. But if the data is not given in a proper arrangement, like not in a descending order or ascending order, then we'll arrange it first. Here also we are seeing that it is arranged already. So what we'll do, we'll just put the formula and get the results. Median is equals to n divided by 2. Here n is 6 divided by 2th observation plus n divided by 2. N is 6 divided by 2 plus 1 observation. In this 2 3s are 6. It means third observation plus, it is divided by 2 actually. Third observation 6 by 2, it is 3. 3 plus 1, fourth observation divided by 2. What is our third observation? Here I'll be writing this. Third observation is our 3 and fourth observation is 4. Coincidentally, they are same, but it can be different. Here it is 7 by 2. Okay. We can divide it. 2 3s are 6, 2 5s are 10. So our median will be 3.5 here. Okay. I hope you got the point. In both the cases, it is different. In odd and in case of even number of data. So this is the formula you have to remember. If you are not remembering the formula, I am going to tell you the shortcut. It's like you have to arrange the data series. Okay. Here, if we are having 5, 7, or 9, then we can easily arrange it, and we can say that this value is dividing the data into two equal halves. So we can directly say, we do not have to put the value and get the result. We can directly say that 3 will be the median. When it is there, like 3 and 4 is dividing the data into two equal half. Now we will simply take the average of it, and we will get the results. We do not have to remember the formula. If we are not remembering, it's also okay. If you got the concept, you can get the result. Okay. Next, next is the mode. Mode is the value of a series which appears most frequently than any others. Most frequently occurring value in a data is going to be the mode of that data series. It is used in agriculture to identify the maximum used input. If we want to identify that in a village or in a district, okay, which uh, which herbicide is being used most by the farmers, or which herbicide is maximum used by the farmers, for say, first we are taking pendimethalin, second we are taking imazethapyr, third we are taking 2,4-D. And we did the survey in the whole district, and we got some results that pendimethalin is used by 15 farmers, 1500 farmers, and imazethapyr is being used by 1000 farmers, and 2,4-D is used by 500 farmers. So from this we can get that this is the most frequently occurring one. So we can say that pendimethalin is used by most of the farmers. So an industry should produce more pendimethalin compared to other two, because it is the consumption of pendimethalin is more. So this is how the mode can be used in agriculture. Okay. Then the bimodal rainfall is found in Tamil Nadu. What is bimodal rainfall? It is a wet season with two rainfall peaks separated by at least one dry month. If I want to explain it to you guys through a graph, then it is rainfall. Here we'll be writing rainfall. Here it is months or the time period. And here we will get two peaks in the monsoon season. Okay. During monsoon, we are getting rain peak. Here, one peak we are getting. And then this period is the dry period. Here, we are getting no rain. And then again, we are getting the second peak. So, this is called as bimodal rainfall. Bimodal rainfall, which is found in Tamil Nadu. You have to remember this state. It can be asked as a question. Okay. A trimodal, this graph can also be formed like this: one, two peaks, and three peaks. If three peaks are obtained, then it will be trimodal rainfall, like that. Okay. Next. So here we'll be calculating how to calculate mode. In the previous example, I said how to calculate, but here we will be discussing by taking a data. For say we have 2, 4, 4, 5, 6, 4, 2, 4, 6, 4. So this is the data series we have given, and we want to find mode of it. Okay. Now what are the values we have? 2, 4, 5, 6. Huh? These are the values. 2 is occurring how many times? 1, 2. It is occurring 2 times. 4 is occurring how many times? It is occurring 1, 2, 3, 4, and 5 times. It is occurring 5 times. Okay. And 5 is occurring how many times? It is occurring only 1 time. 6 is occurring how many times? It is occurring 2 times. So here we can say, as the 4 value, the value of the series 4 is occurring 5 times. So we can say that this data series Mode is 4. I hope you guys got the point what I want to say here. Let's move to the next slide. Next is geometric mean. If there are n items like x1, x2, like that x to xn, then the geometric mean is defined as nth root of product of items. Let's derive the formula. Simply what we have to do, we have to just follow the definition. It is the nth root of product of item. What is this product of items? What are the items given? x1 to xn. So what we'll do simply product means multiplication. x1 dot x2. Like that we will be multiplying till xn. And it is nth root means 1 by n. This is the formula of geometric mean. Geometric mean formula can be directly asked because you do not have to solve this in the examination. In JRF kind of examination, they generally do not ask this. Okay, but you have to remember this formula. So if it will be coming like which of the given is the formula of geometric mean, of calculating geometric mean, then you should know how to calculate which formula is to be used. It should be noted that geometric mean cannot be calculated if any item is either 0 or negative. If any of, because it is a product, if any of the item will be 0, then the whole geometric mean will be 0. That cannot take place. So if any item is 0, we cannot calculate geometric mean. If any item is negative, we cannot calculate geometric mean. This you should remember. Geometric mean is used for bacterial growth and cell division measurements. This is very important. Generally, we use geometric mean for calculating bacterial growth and cell division measurements. It is suitable where data is expressed in terms of rates, ratios, and percentage. It is the most suitable when the observation of smaller values are given more importance or weightage. This is important. This is important. This is also important. Actually, the slide is important. Okay, this can be asked. These three can be asked in the statements. Kind of statement. It can four of the can come as statement. Which of the following is correct? Or they might change something from this and can ask which of the following is incorrect about geometric mean. So you should know this. Let's move to the next slide. Let's come to the harmonic mean. It is the fifth measure of central tendency. The harmonic mean is the reciprocal of the mean of reciprocal of the values. You might have not got the point by reading this, but let me explain you. It's very easy. Harmonic mean is simply, it is telling the reciprocal. First word is reciprocal, so we will just do that 1 upon. Okay. Then mean of reciprocal of the values. If the values are x1, x2 to xn, then what we have to do, we have to calculate the mean of reciprocal of the value. So first we'll do the reciprocal of each value, 1 upon x1, 1 upon x2, like this, 1 upon xn. And we have to calculate the mean. It means we have to add it and we have to divide by number of observation. So what we'll do, 1 upon x1 plus 1 upon x2. Similarly, we'll be adding till 1 upon xn. And we have to divide it by n. But rather dividing by n, we can also write it as 1 upon n. Okay. This is the simplest formula. You can understand uh, by seeing the, you can not understand it by reading the simple definition, but you can understand by this equation. Okay, I just have derived from this definition. So this is very easy and it can be asked as a question which of the following is the formula of calculating harmonic mean. So you should know that. Okay, next. Two relationships which you have to remember is first is that arithmetic mean is greater than geometric mean and geometric mean is greater than harmonic mean. How you will be remembering that? It's a very easy trick that we know A, B, C, D, E, F, G, H. We are studying from childhood. Okay. So first is coming A. So we are putting arithmetic mean will be the largest. Then is coming G, then geometric mean, then is coming the H, then harmonic mean. Simple. The second relationship is geometric mean square is equals to arithmetic mean into harmonic mean. I hope you got these both of the relationship. This can be directly asked in the question, which of the following relationship is correct or which of the following is correct. So you should remember this. Next is relationship between mean, median, and mode. This relationship is not a mathematical relationship. It is an empirical relationship. What is it? Empirical relationship. What is an empirical relationship? It means this is based on research. Scientists have done much research on it and then got a new relationship between mean, median, and mode. So it is not a mathematical relationship. Okay, it is an empirical relationship. It is near to correct. We can say that it is near to correct. Like we say, E is equals to mc square. This is a mathematical relationship. If we'll multiply mass with the speed of light, we'll get the energy, exact energy. But here in case, we'll not get the exact, but will be somewhat precise to the correct. It is near to the correct. Okay, now we'll be calculating that mean minus mode is equals to 3 mean 3 into mean minus median. Okay, now we'll transfer this mean here. First, we'll write it as it is. Mean minus mode is equals to 3 mean minus 3 median. Okay. Then we'll transfer the mean here. So here it will be minus mode is equals to 3 mean minus mean, which is coming from there, minus 3 median. Okay. So here minus mode will be as it is. By subtracting it, we'll get 2 mean minus 3 median. Okay. Then what we have to do, we'll be multiplying both side by minus. Then it will get cancelled and here we will get mode. Here we will get 3 median because minus will multiplied with minus and it will be plus. So 3 median plus, sorry, it will be minus. Wait a minute. 3 median, it will be coming minus 2 me. So this is the relationship you should remember. That mode is equals to 3 median minus 2 mean. So here which type of question you can get? First, they can shuffle this and can make a new relationship, but you should remember this one. So you can shuffle and get the which is given in the following that options. So you have to remember this. And second question they can ask is they can give median or mean and they can ask you the how to calculate the mode, or they can give mean and mode and tell you to calculate median. So you can shuffle and get the answer. I hope this is clear to you. Next, we'll go for the questions. So the question is, which of the following measure of central tendency is used for studying qualitative data? So it is mode or mean or median or geometric mean. So we studied that qualitative data we generally we use for median. We go for the qualitative data for median. So median is the correct answer. Okay, next. Find the correct order. Just I tell you, like they can ask you in the what is the correct order. So I tell you that from A to H, G will be coming. So it will be A, G, H. So which of the following is correct? Arithmetic mean, then geometric mean, then harmonic mean. Third option is correct. Option C is correct. Okay. Next, the question is, which of the following measure of central tendency is used for bacterial growth and cell division measurements? So options are arithmetic mean, geometric mean, harmonic mean, or all of the above. We said that this bacterial growth and cell division measurements, we go for geometric mean. To calculate these, we go for geometric mean. So option B will be correct answer here. Fourth is reciprocal of mean of reciprocal values is known as. We just studied this. This is harmonic mean. That option C is correct here. Fifth is find out the correct relationship. So we studied that gm square is equals to an into hm. So which of the option is correct? It's the first one. Okay. I hope you got the concepts and I'm able to make you understand things. Thank you and we'll